Hey everyone, so I'm going to be doing number 23 from the controls homework 2, and number 23 is y double prime plus 2y prime plus y equals 4 times e to the negative t. Our initial conditions are y0 equals 2 and y prime is 0 equals negative 1. So I'm going to be solving this using Laplace transforms, and I'm going to start by doing the Laplace transform of the original equation. Simply, I'm going to do the first term. So for Laplace transform of y double prime, it's going to be equal to s squared times y of s minus 2, just kidding, s times y of 0 minus y prime of 0. And that is the Laplace transform of y double prime. And in plugging in our initial conditions, get s squared plus times y of s minus 2s plus 1. Now for 2y double prime, for 2y prime, it's going to be 2 times the quantity of sy of s minus y of 0. Which is Laplace transform of 2y prime. And plugging in the initial conditions, we get 2s y of s minus 4. And now for y, the Laplace transform is simply y of s. Laplace transform of our input for e to the negative t, we get 4 over s plus 1, which is the Laplace transform for e to the negative t. So now we did the Laplace transform of each term in the original equation. We can now combine them and then simplify it and solve for y of s. And this is what we have once we put our equations together. Y of s times the quantity of s squared plus 2s plus 1 minus 2 of s plus 1 minus 4 equals 4 s plus 1. And in solving for y, we get y of s equals 2s squared plus 5 of s plus 5 over s plus 1 cubed. And how I got this is that this term can be reduced to s plus 1 times s plus 1, which equals to s plus 1 squared. And before I bring this term over to the other side, I brought all these terms to the other side, and then I divided this through, and since there's already an s plus 1 here, and therefore I was able to get s plus 1 to quantity cubed. And I put everything in a common denominator, which is s plus 1 quantity to s plus 1 quantity cubed. Now I'm going to solve for y of t by using partial fractions. So ts squared plus 5s plus, probably right meter, over s plus 1 cubed is equal to a over s plus 1 plus b over s plus 1 quantity squared plus c over s plus 1 quantity cubed. And then putting everything under a common denominator for this side, we get, and this is all equal to this term still, it's equal to a s plus 1 squared plus b times s plus 1 plus c all over s plus 1 quantity cubed. And reducing and cleaning this up, this is equal to as squared plus 2as plus a plus b s plus b plus c, which is, and this side corresponds to this, so therefore combining all of our s squared terms together and seeing there's only one s squared term on this side, therefore a equals 2. Since there's only one s squared term up here and a is the only s squared term down here, therefore the coefficient a must equal 2. Therefore the coefficient 2as plus b must equal the coefficient 5 from the original numerator. And since we know a is, there should not be an s here. Since a is 2, therefore it turns out to be 4 plus b equals 5, therefore b equals 1. And for the coefficient 5 here, we get a plus b plus c must equal 5. And knowing that a is 2, b is 1, therefore c is 2. And plugging these values back into here to solve for y of t, we get y of s equals, gotta look up, 2 over s plus 1 plus 1 over s plus 1 quantity squared plus 2 over s plus 1 quantity cubed. Just gonna double check to make sure that's right. And that's right. And doing the inverse Laplace transform of every term to get y of t, we get y of t equals, y of t equals 2 times e to the negative t plus t times e to the negative t plus t squared times e to the negative t. And that is our y of t. Yeah, hopefully this was a helpful video, and thank you for watching.